Hello everybody, this is Jithin P. Narayanan, Assistant Professor, Department of Mechanical Engineering, Rajagiri School of Engineering and Technology, Cochin, affiliated to Kerala Technological University. This presentation is on Introduction on Mechanisms. That is a topic from the course ME 301, Mechanism Machinery. This course is offered to 5th semester Mechanical Engineering students. Let's move to the presentation. The study of mechanisms can be divided into following disciplines. Kinematics and dynamics. In kinematics, we will be dealing with the motion study of a mechanism, or we can say we will be dealing with the relative motions of different parts of a mechanism without taking into consideration the forces which produces this motion. But in case of dynamics, it involves a calculation of forces which is impressed upon different parts of the mechanisms. Forces can be sometimes static or dynamic forces. So dynamics is further subdivided into kinetics and statics. Kinetics is actually study of forces when the body is in motion, whereas statics deals with forces when the body is in stationary. So in this subject, we'll be mostly dealing with the kinematics part of the mechanism. That is, we will be studying the motion of a mechanism without taking into consideration of the forces which produces that motion. So study of mechanisms, study of mechanism, that is in kinematics, it involves two parts. That is analysis of the mechanism, which will be the motion analysis, not the force analysis, because we are not considering any forces which causes that motion. We are only focusing on the motion of the mechanism. So the analysis part includes the motion analysis and also the synthesis part. Synthesis part involves the design of different parts of the mechanisms. Analysis part involves the study of motion and which causes the different parts of the mechanism to move. However, the study of relative motion parts does not depend upon the strength and actual shape of the mechanism. We are not dealing with the strength of the parts of a mechanism or the actual shape of the parts of the mechanism. So, for example, you can see here in the figure that actually represents a mechanism which is called a slider crank mechanism. That can be that this diagram is actually a line diagram. This diagram actually represents a IC engine, or it may be sometimes representing a compressor, reciprocating compressor, or it may be sometimes representing a reciprocating pump. In case of a reciprocating engine, IC engine, we know that the displacement of the piston which is represented by the link 4 or the sliding block link 4, you can see from the figure. The displacement of the piston actually depends upon the length of the connecting rod and the radius of the crank. All these things are the factors which depends the displacement or the distance covered by the piston when the crank is rotating. So that is actually the analysis part of the or the motion analysis part of the mechanism. And in order to design such a mechanism, or in order to design a mechanism to get the desired output motion, we need to synthesize the mechanism. That means we need to design the particular mechanism to get a particular output motion. So mechanism, the definition of a mechanism, it is actually a number of bodies, or we can say it is number of links or members which are assembled, or we can say it is connected in such a way that the motion of one causes constrained and predictable motion to others. Then it is known as a mechanism. So constrained means we know that when two links are connected, we are actually arresting motion of that link in some of the directions. That is actually called constrained motion. When two links are connected, we know that it cannot move in some direction, or it cannot sometimes rotate in about a particular axis. So that is what is called constrained motion. So when we are connecting links, we are actually constraining the motion of each links or each members. Why we are connecting these things? Because we need a particular motion in the output link. If you are providing a particular motion to the input link, we need a particular motion in the output link. So we are able to predict what will be the output link motion if we are giving a motion to the input link. So we are able to predict the motion, and the motion is a constrained motion. And then we can say that it is a mechanism. From the figure itself, it is representing in the line diagram. I told you that is representing line diagram of a Either it will be a IC engine, or it will be sometimes a compressor, reciprocating compressor, or a reciprocating pump. In case of an IC engine, if this diagram represents an IC engine, the link for which is called a slider, or in case of IC engine, it will be the piston. Due to the combustion, the piston will be moving downwards from the outer dead center to the inner dead center, to moving. And we can say that the crank, which is the link to, it will be rotating. So we are able to predict what will be the motion when the slider moves. Okay, so a predictable constrained motion is what is the definition for a mechanism. So mechanism is number of bodies which are assembled in such a way that the motion of one causes constrained and predictable motion to others. So then only it will be known as a mechanism. So we discuss what is a mechanism is meant by. So in mechanism, we know that it is formed by connecting different elements or different members or different links. So in the previous figure, we know that link is actually is the smallest member in a mechanism. For example, in a slider current mechanism, which is represented in the previous slide, piston itself or the sliding bar itself is a link. Connecting rod is another link. Crank is another link. Fixed link, that is the crank is connected to a fixed part or a frame. That is another link. So each links are connected to get a constrained output predictable motion. So that is what is a mechanism meant by. If such mechanisms are connected each other, then it forms a machine. For example, in case of IC engine itself, we know that the piston is enclosed inside a cylinder. The piston, connecting rod, crank, and the fixed frame. That is, the cylinder itself is a fixed frame, and the crank is connected to the crankshaft. Crankshaft in case of slider crank mechanism is considered as a fixed frame. So that is actually a mechanism, slider crank mechanism, but that only doesn't form an IC engine. Okay, there are some other mechanisms which is interlinked or connected to this mechanism to form the complete IC engine or the complete machine. Okay, for best example is that we know that inside a cylinder there will be two valves, that is inlet valve and the outlet valve. The opening and closing of this inlet valve is controlled by the camshaft, in which there will be cams. Cams will be connected to the input and output valves. So this opening closing is controlled by the motion of this camshaft. Similarly, in case of output, that is the crank is connected to the crankshaft. The crankshaft, it will contains different other several other cranks, which is connected to the cutting rod of other other engines. And this crankshaft, at the end there will be some clutch mechanisms. There will be flywheels. So a lot of mechanisms are attached to this mechanism to form the complete machine. So a machine is actually a combination of mechanisms, and it is a device for transferring or transforming certain motion and force from the source to the load. For example, in case of IC engine, the chemical energy or the energy due to the combustion of the air fuel mixture, that is the chemical energy, is converted to mechanical energy. This mechanical energy sometimes will be connected to, if the IC engine is connected to a generator, then it will be producing electrical energy. So there is transferring and transforming of motion, and due to this motion, the energy will be produced, or there will be change in energy or transfer of energy from one form to another, from a source to the output load or the resistance. So machine is a mechanism or a combination of mechanism and a device for transferring and transforming motion and force from a source to the load. Load means actually the output. Best example for this is automobile engine. That is what I have described. What is the difference between a machine and a mechanism? We know that machine is actually combination of different mechanisms. So machine actually modifies mechanical work, but mechanism transmits and modifies motion. Machine modifies mechanical work. That means I told you, if this IC engine is connected to a generator, we are actually changing the mechanical work to a electrical energy. That is, we are converting mechanical energy to an electrical energy. Inside the machine, there is a transfer of there is a modification of work, or we can say modification of energy. That is, inside the engine, IC engine, there is a chemical energy. It is due to the combustion, we are producing heat energy. That chemical energy is then converted to mechanical energy, and from mechanical energy it is converted to electrical energy if you are connecting that IC engine to a generator. So that is actually modifying mechanical work. Mechanism actually transmits and modify the motion. And machine is a practical development of any mechanism. A mechanism is a part of a machine. Okay, we can say mechanism is only a part of a machine. A machine may have a number of mechanisms for transmitting mechanical work or power. Actually, a mechanism is a skeleton, or we can say it is an outline of the machine to produce motion between various links. Rigid and resistant bodies. You have studied in rigid mechanics. That is, the first assumption was that the bodies which we are going to analyze are assumed to be rigid bodies. That means it doesn't undergo any deformation on application of forces. But in real scenario, it is not like that. On application forces, the body deflects, or sometimes the body undergo deformation. If the force acting on the body is beyond yielding limit, it undergoes deformation. And what are resistant bodies? Resistant bodies are those which are rigid for the purpose they have to serve. One of the example is a belt. You know that the belt, when subjected to tensile force, it undergoes deformation. But when the belt is connected to a pulley, and when the pulley works or the pulley rotates, the belt doesn't undergo deformation anymore. So the belt during working condition, it is acting as a rigid body. Such bodies, when they are rigid, when they act as rigid bodies for the purpose, they are considered as resistant bodies. Similar is the case of fluid. We can see that in fluids, we say that we assume in certain analysis that fluid is incompressible. This is because for that analysis in that particular condition or in that particular force condition, the fluid doesn't undergo any deformation. But in real scenario, on application of force which is beyond or which is above the compressibility limit of a particular fluid, it can compress. So in real cases, it is compressible. But consider if we consider hydraulic press, inside that there is a fluid which undergo compression, which is applied by compressive force, but does not undergo any compression because the limit of the external force which is acting on the fluid is not beyond the compressibility limit of the fluid. So when in such cases, that is in hydraulic press, fluid act as a rigid body. That is for that purpose it is acting as a rigid body. So such bodies which act as a rigid body for that purpose is what is called resistant bodies. In our mechanisms, that is in planar mechanism which we are going to study, all the links are assumed to be rigid, resistant body instead of considering it as a rigid body. That is for the purpose, that is for when the mechanism works, all the links act as a resistant body. That means all the links act as a rigid body for the purpose. Links. It can be considered as the building block of a mechanism. We know that the links are connected each other or combined each other to form a mechanism, and they have relative motion between them. Consider a slider cam mechanism which I have shown in the previous slides. In that there are four links: the fixed frame which is considered as link 1, the crank which is considered as link 2, connecting rod as link 3, and the slider as link 4. There will be always a fixed link for a mechanism, a fixed frame for a mechanism to which it will be connected. The links can be classified into binary, ternary, and quaternary links depending upon their ends on which another link can be attached or placed, and so that the pair becomes a revolute or a turning pair. We will discuss what is actually a turning pair or revolute in the coming sessions. You can see binary link, a figure has been shown below. It has two endpoints. To the two endpoints we can connect another link. So when we connect a link to one of the end of the binary link, then the pair of link become a revolute or a turning pair. That is, it has a rotation only one axis. That is what is called turning pair or revolute pair. In detail, we will discuss about turning pair in the coming sessions. Similarly, you can find a ternary link, a figure that shows a ternary link. There are three points to which we can connect another link. In quaternary links, there are 4 points to which we can connect another 4 links. Both ternary and quaternary link has been shown as a shaded figure. That means it is actually a rigid frame. The ternary link doesn't mean that it has 3 links. It is actually a rigid frame, and the links with which we are forming a ternary link doesn't have relative motion. So all these three, that is as shown in the figure, you can see. I will show by using the pointer. These 3 links actually they are fixed. Okay, that doesn't have any relative motion. So it acts as a frame, and to the vertex we can connect other three links. Similarly, this is actually a frame. Okay, this is one link, two, three, four links can be welded together to form a quaternary link, and we can connect four links to the ends, and such a link is called quaternary link. So that's all for today's for this session, and we will continue in next section with kinematic pairs. In next session, we will discuss on kinematic pairs or different types of kinematic pairs. So next session will be named as Module 1, Part 2. Thank you.